Welcome to Factoring 101. This is for those of you who still are a little unsure with how to factor basic polynomials, such as this one right here. So let's go ahead and talk about this. And I think the thing that we need to ask ourselves is, before we ask, how do you factor this? Which the answer is you set up two sets and look for factors of the third number that sum to the middle number. Is how do you even get something like this in the first place? Because it's really easy to get lost in the whole how do you do things and forget why we do them. So thinking about this, where do you get something like this, a trinomial with two different exponents? And I have a couple of examples here to show you just that. If you remember from the last unit, how do we multiply these two binomials? Well, we set up a box, right? We use the box method. And if I set up a box here for the first one, you know that x and 2 go on one side and x and 5 go on the other. And if I do this correctly, I'll get x squared, and then what goes here? 2x, and then 5x, and then 10. And then from here, I have to actually add all of these up. And notice I actually get a trinomial because I have like terms right here. So with that in mind, we've done it. That is where our trinomials comes from. It comes from multiplying two binomials together. Just to make sure you know what you're doing, how about you go ahead and on your own try to multiply this out and see what you get. Now, if you do it correctly, you should get something like, I'm not going to show the work here, should be 2x squared. And then you actually are going to get some things to cancel out here, and you're actually going to end up with minus 18, interestingly enough. Very good. Now, on the next page, I just want to approach this original problem the same way, assuming that we need to multiply two binomials. And the question is, what two binomials will that be? From the get-go, you know that this has to be x and x, because that's the way you get x squared. Now, my question is, how do we get this number? Because this is what came from here, if you remember from the last slide. This number 10 ended up being in the back of our polynomial. So where does this 3 come from? How do I find what could multiply to give me that 3? Well, the only right answer that's possible for 3 is, well, the only factors of 3, 1 in itself. That's kind of nice to factor when you have a prime number there. So I already know that this is going to be 3, and this is going to be 1, and that means 3 times x is 3x. And I'm just checking my work now. 1 times x is x, and that these two, in fact, will add to give me my 4x in the middle right here. Awesome. Now that we know that, we can take any perfect 3 trinomial, I shouldn't say perfect, just any trinomial, like x squared plus, 4x plus, let's say 4, for example. And I can factor it by saying what numbers multiply to give me 4 and also add to give me 4. And you always set up two sets, so you should do x and x. And what are those two numbers in this case? They should be 2 and 2, which leaves you with x plus 2 times x plus 2. Let's see if you can do one more with me. Again, let's this time try something a little bit harder. Let's do x squared. Oh, let's see here. I'm going to leave a blank there. Plus, you can sort of see in my head how I'm making these up. Let's do 70. And then let's see here. We'll do 17x. So I'm looking for factors of 70 that add to 17. Go ahead and find the answer to this one. See what you get. If you did it correctly, you should have gotten x plus 7 times the quantity x plus 10. And that's pretty much all there is to it, guys. Just factors of the third number that add to the second number. You just need some practice with doing that, and I think you'll be fine after that. Thanks, and good work. Good luck on the next one.